video, I want to go over the review worksheet over Chapter 7 over hypothesis testing. The first question deals with a chi-squared test and finding the critical values from the chart. So if you remember, when we look at the chi-squared chart, it is always the area to the right. So we got to think about that based on the type of test it is. So if it's a right-tailed test, n is 20, alpha is 0.05. When we look at our chart, we will be at 19 is our degrees of freedom. And it is 0.05, and that is to the right. So we can go right down from 0.05, and we can get 30.144, which is the answer. Let's jump down to the left-tailed test here where n is 6. That means our degrees of freedom is 5. It's 0.1, but because our chart's to the right, we would need to look at 5, and we would need to go to 0.9, which would be right here, 1.61, which once again, you can see as our answer. If it is a two-tailed test, remember we need to take our alpha and split it into 2. So if we split that, our first will be 0.005, and then the second is 0.995. We go to a degrees of freedom is 13, and we can go to our chart, and we get those two numbers. All of the rest of the problems here are going to be hypothesis testing, and the question is going to be, what type is it, is one of the first things you want to think about. So really one of the first questions you should ask is really this part B, and think about what type of test this is. So in this case, it says the nutrition bar manufacturer claims the standard deviation. So that's in telling you the standard deviation, that tells you it is a chi-squared. So notice our null and alternate hypothesis is sigma is equal to 1.11, and sigma is not equal to 1.11. We calculate our test statistic for chi-squared over here. Remember, this is S, this is sigma. We have to square it because it's the standard deviation, not variance. And then we find our critical values in our region. We find our 28.73, which is not in our critical regions, so we fail to reject. Notice here as you do these problems, if it's a chi-squared, you will have a test statistic and you will have the critical region, and there is no p-value. If you have a z, t, or p test, in those cases, you have the critical value. So it depends on the type of test that it is, what you have. Okay, so for these three, we have a p-value. For chi-squared, we have our critical region. And since we fail to reject the null hypothesis, we fail to reject that, we say there is not enough evidence to support that the standard deviation is different than 1.11. Let's look at the next one. The Nero Match Company sells matchboxes that are supposed to average 40 matches per box. So that's an average, so that is a mean. So now we need to decide, is this a Z or a T? And the answer comes from right here. They give us sigma is 9, which tells us that is a Z. And so we now have a p-value. We do not have a critical region. We do not have a test statistic. And we can put this into our calculator. If you have the calculator, as you know, you can do a z-test. You can type your information in there to get your answer. If you do not have the calculator, you can use the GeoGebra T, Z, and P test to get our p-value, as we've looked at earlier this week. Once you have your p-value, you compare it to alpha. If it is less than alpha, then you reject the null hypothesis. And since we reject the null hypothesis, we say there is enough evidence to support that the average box has more than 40 matches. So the next one. A hospital reports that the normal death rate for patients with excessive burns is more than 40% of the skin area, has still reduced the amount of time used by a new plasma compressors. Before the new treatment, mortality rate for extensive burn patients was about 60%. Using the new compressors, the hospital found that only 40 of 90 burn. Is there enough use 1% level of significance to test the claim that the mortality rate has dropped? So before the mortality rate was 60%, and now we're testing the claim that it's gone down. It is a p-value. So we have a p-test that we need to find our p-value. Once again, because it's a p-test, there is no critical region, there is no test statistic. Now on this one, let's go through and show how we would do this on both the calculator and GeoGebra. So we go to stat. The test we are doing is the one proportion z-test. Our p is 0.6. Slide over here. Our x was 40. Our n is 90. This is less than 60%. It is a left-tailed test. We calculate our p-value, and our p-hat is 0.44, and our p-value is 0.00129, 0.0012. So that is less than alpha, so that means we reject this, our null hypothesis. Now, let's talk about how you would do this same thing if you didn't have the TI-83 calculator, but if you had to do it in GeoGebra. And the big thing to remember is GeoGebra, it uses p-hat. It doesn't use x. So it doesn't use 40, it uses our p-hat value. So if we go here, we have our sample proportion, which is 0.44444. We go to our sample size, that's our n, that's 90. Our hypothesized proportion, that is 0.6. And if you remember, I'm just highlighting the next one here by hitting the right arrow. And the tail, it is a left-tailed test, so I have to put parentheses, and I do the left-tailed, and let me delete this. Remember, you put the parentheses around it when you do it, and now you can see this first number right here is our p-value, 0.00129, which is 0.129, the same thing we got on the calculator. You can see those two numbers are the same. You also see the -3 here, but we don't use that for what we're doing here. So that tells us that our p-value is less than alpha. So we reject the null hypothesis, which means there is enough evidence to support that the mortality rate has dropped, and it is less than 60. Our final one here is a company makes electronic trains with the motor that claims its average is only 0.8 under the normal load. So 9 motors are tested. It's found the X bar is 1.4 with a standard deviation of S. So therefore our mean is greater than 0.8 and is less than or equal to 0.8, and it is a t-test. So no test statistic, no critical region. We go back to our calculator or GeoGebra, whatever you are using. It is less than alpha, so we reject the null hypothesis, and we say there is enough evidence to support that the claim of 0.8 amps is too low. So here's the claim that it is too low. Okay. So there's our 4 types of hypothesis tests that we have that we're looking at here. A t-test, a p-test, a z-test, and a chi-squared test. So the big thing is to recognize which type of test each one is, and then the information you're going to find. If it's chi-squared, that is the one that you have to look up in the chart. You kind of need to draw the picture. You need to calculate the critical region and the test statistic, and see is the test statistic in the critical region to decide if you reject or fail to reject. Okay, so that's that one. The other types, we can find our p-value on the calculator. Okay, on the calculator. So that is the review of Chapter 7. You're now able to take the test over Chapter 7.